Overview and background. Bioethanol is a renewable fuel made from plant biomass like corn, sugarcane, and switchgrass. It's used as a gasoline additive to improve octane and reduce emissions. In the United States, nearly all gasoline contains some ethanol, typically in blends like E10 or E15. Source cultivation. Feedstocks for bioethanol are grown using conventional agriculture or specialized systems like algae ponds. These plants capture solar energy through photosynthesis, converting CO2 and water into sugars. High-yield crops like corn and sugarcane dominate current production, while switchgrass and algae are being explored for sustainability. Production processes. Fermentation. Microorganisms such as yeast convert those sugars into ethanol and carbon dioxide under anaerobic conditions. Hydrolysis. Complete carbohydrates like cellulose or starch are broken down into simple sugars using enzymes or acids. Respiration. During fermentation, microbes respire by metabolizing sugars to release energy, producing ethanol as a byproduct instead of a fully oxidizing into CO2 and water. Development status. Corn-based ethanol is widely available and commercially deployed across the United States. Cellulosic and algae-based ethanol are still in development. With pilot projects supported by the Department of Energy, these advanced fuels aim to reduce land use and improve carbon efficiency. Carbon footprint impact. Bioethanol reduces greenhouse gases emissions compared to gasoline, especially when made from cellulose sources. The CO2 released during combustion is partially offset by the CO2 absorbed during plant growth. Some pathways can cut emissions by over 80%, depending on feedstock and processing. Economic impact. Bioethanol supports rural economies through farming, refining, and distribution jobs. It reduces dependence on imported oils and stabilizes fuel prices. Its compatibility with existing engines and infrastructure makes it economically viable at scale. Public communication. Government agencies like DOE promote bioethanol through educational campaigns and outreach. Public messaging emphasizes ethanol's environmental benefits and vehicle compatibility. Resources like Energy 101 Biofuels helps customers understand its role in clean energy. Current analysis and recommendations. Bioethanol is a mature biofuel widely used in the United States and Brazil, primarily from corn and sugarcane. Its compatibility with existing vehicles and infrastructure makes it a practical short-term solution for reducing petroleum reliance. However, conventional production raises concerns about land use, food competition, and energy intensity. Advanced pathways like cellulosic, ethanol, and algae-based fuels offer great sustainability, but remain costly and technically challenging. From a carbon perspective, bioethanol can significantly reduce greenhouse gas emissions, especially when derived from cellulosic sources. The recommendation is to maintain support for conventional ethanol while aggressively funding research and infrastructure for advanced biofuels to maximize environmental and economic benefits. Plan of action. Feedstock innovation. Expand cultivation of non-food crops. Invest in high-yield, low-input agricultural systems. Process intensification. Fund advanced pretreatments and hydrolysis technologies. Energy microbes for more efficient fermentation. Infrastructure expansion. Build nationwide biorefineries with integrated waste-to-energy systems. Increase E15 and E85 fueling stations and flexible fuel vehicle adoption. Public engagement. Launch education campaigns to bioethanol's benefits. Partner with communities to promote clean energy awareness. Sustainability safeguards. Implement rigorous life cycle carbon accounting. Ensure land use and water stewardship practices. Citations.